Okay, so I can start setting my plotting sheet up initially. I'm told that there's a vessel on a course 344 travelling at a speed of 12 knots. So the first thing I'm going to do is actually plot 344 on my plotting sheet. And I've just left a little bit just back beyond my DR position there, so that I can run stuff back if I need to. So 344 degrees true at 12 knots. The next thing I'm going to have to do with this question is just make sure I know what time I'm fixing the position for, and if I need to make some adjustments using run distances, because you can see that we've got 3 observations of bodies. I want the fix at 1952, but actually I've got one at 1946, one at 1952 and one at 1958, so I have to work out some run distances for this, and I'll just use the bottom of my plotting sheet to do that. So I'm just going to set up a few columns here really to make it easier for myself. The first one obviously is going to be the star, assuming these are stars. The next one is going to be the time that I want to do the fix, so I'll call that time of fix, and the next one will be the time of observation. And I'm going to just put minus signs down in between those 2 columns just to remind me. So star A, star B and star C. The time that I want the fix for is 1952 in every case, obviously. And the time of observation in the case of star A was 1946. In the case of star B was 1952. And in the case of star C was 1958. And I've got time differences now that I can calculate, and I'm going to put positive and negative signs on these just to show which ones resulted in a negative result in the calculation and which ones had a positive result. So the first one, 1952 minus 1946, I've got a positive result there of 6 minutes. 1952 minus 1952, there's no time difference there at all, and 1952 minus 1958 gives me minus 6 minutes. So what I've got here is everything that happened earlier than the time I want my fix for comes out positive, and everything that happened after the time I want my fix for comes out negative. And that's why I've arranged the table in this way, because if you do this every time, you will always get a positive value for things that are going to get run on and a negative value for things that are going to get run back. The last thing I'd need to do though before I can mark my run distances is work out what kind of distance those 6 minutes actually equate to, because if I'm doing 12 miles in an hour because I'm going at 12 knots, how much of that am I going to travel in 6 minutes? For some of you it might be very obvious that 6 minutes is going to be 1/10 of an hour, so you can simply divide 12 by 10. But just in case you get some slightly odd numbers to work with, I'd recommend you take your speed. So in this case it was 12 knots, divide it by 60 to find how far you go in 1 minute, and then just multiply it by the number of minutes, and it obviously has the same result. So I'm going to add another column for distances here, and in my distance column I'm going to have plus 6 minutes is going to be 1.2, and that's going to be on because it's positive, and minus 6 minutes is going to be 1.2, and that's going to be back because it's negative. So these turns of phrase on and back refer to run distances. Obviously B, there's going to be no run distance at all. I'm actually just going to plot that one from the centre of my plotting sheet. So we'll measure off the run distances initially. I'll use my compasses. And I'm going to be running 1.2 on and 1.2 back. And the run on star, I'm actually going to plot star A from this point, and I'm going to be plotting star C from this point, and B I'll just plot from here.